Hello. Now we're going to be having a look at natural numbers today. Now natural numbers is a funny sounding word, as we often have in maths, but it just means the numbers that we're already familiar with. So we're starting, as we always do, with what we already know in maths, and we're just going to learn it by a slightly different name depending on what you would have learned before. But natural numbers just means the numbers you're going to find in nature. So we could have one of something, or two of something, or three of something, and so on up. So the definition for our natural numbers is the set of all positive whole numbers. Well, we know what a set is. We've looked at that already. We know that it's a well-defined group. So we know exactly what numbers should be in the group natural numbers. Positive means that it's bigger than 0. So we know that it's going to be positive numbers like 1 or 10 or 250 positive numbers, and we know that they're going to be whole numbers. Now a whole number comes down to whether we're dealing with numbers that are divided by 1 or numbers that are divided by any number other than 1. So if we had 3 and it was a whole number, that would mean it would be 3 divided by 1. Later on in the year, we're going to look at fractions, like you've already dealt with before, where we might have a half. Now a half is not called a whole number because it doesn't make up a complete unit. It's not a complete thing, it's half of a thing. So we will be coming back to the idea of whole numbers and fractions later on, but for right now, we have all of the numbers we're dealing with are divided by 1. They're all called units, or they're big blocks unto themselves. So if we had chocolate bars, we'd be dealing with whole chocolate bars instead of bits of chocolate bars. So we're dealing with whole numbers. So that's our definition, and as we often do in maths, we're going to look at the key words in our definition. And now we're going to have a look at what that would mean in practice if we had to write out the set. So I've started it for us here. N, capital N, is the name for the natural numbers. It's a fairly sensible name for it. And we know that we use a capital letter for our natural numbers. And then I have an equal sign, and then I have a curly bracket, and now I have my different elements of my set listed out with commas in between them. So I start at 1, that's the smallest natural number. So 0 is not a positive number, so it isn't in our set. So our smallest natural number is 1, and then 2 is the next one, 3 is the next one. Well, what would be the next one? It would be 4, then 5, and we remember in our sets that we don't have to go in order, so we could say that the next one would be 103, but as I've said to you before, it's often easier to follow in order. Now, the difficulty we have to deal with is that this is all positive whole numbers. So we run into a little bit of a difficulty if we try to write out the whole set. Up until now, we've been dealing with sets. We were able to just write everything out, and then at the end we could put a curly bracket and we could see all of the elements in our set. But we can't do that with natural numbers because I already wrote down 103. We also have 1,032 and 1,064, all the way going up forever and ever and ever. And we can't sit here forever and just write out the elements of our set. So at some point we have to say, well, this just keeps going. And the way that we say this just keeps going is we put down 3 dots and then we close our curly bracket and we say these 3 dots stand for all of the other numbers that keep going, but we're not going to write down. So it's important when you're giving the definition of your natural numbers that we're going to start at 1 and go up 2, 3, 4, 5, 6, 7, and then when we feel that we've written enough of them, then we're going to put dot, dot, dot and close our curly brackets, and our dot, dot, dot does all of the work for us, that we don't have to write down every single number that exists in our set. So that's the definition of natural numbers, and we have to know what it is. You've already seen in maths that we are very specific on the language that we use, and we have to be careful that we know what our words mean and how we can use them. So we have to know our definition of natural numbers. Now, beyond that, you already know the next part very well, but I'm just going to remind you of it. We have even numbers are numbers that are divisible by 2. They're divided by 2. So we'd have something like 2 would be an even number, or 8 would be an even number, or 50 would be an even number, because we can divide all of them by 2. They're all divisible by 2. Now the alternative, the other thing that can happen, is if a number is not divisible by 2, it would be an odd number. Well, what would be an example of an odd number? 5 is an odd number. 9 is an odd number. These numbers, if we try to divide them by 2, we end up with fractions. We end up with not nice looking numbers, so we say that they're odd numbers because we can't divide them by 2. Now, our next step is to just look at some language when it comes to how we're going to work with natural numbers. And we already know adding and subtracting. We've been doing it for years. When you see problems written in or questions written in English, you will often see that we will call adding the sum of numbers, and we use our plus sign, and subtracting will be called the difference of two numbers. And we'll look at an example of that in a moment. But if you're seeing the word sum, it will usually mean adding, and if you're seeing the word difference, it will usually mean subtracting. And they're just different words for exactly the same idea. Now, let's have a quick look at a few examples, and what will be really critical for our work this time round is going to be our number line. So you can see the number line here at the bottom of the page. We have the numbers from 0 on up to 30. Now we know that 0 is not a natural number, but all of the rest of these numbers down along the bottom of the page, all the way up to 30 and beyond, are natural numbers. So let's have a look at some examples of adding and subtracting. So if we start off with 9 plus 3. Well, what are we going to do? We're going to start at 9 on our number line, and we're going to add 3. So if we're adding 3, are we going to get bigger or are we going to get smaller? Well, we're going to get bigger. So we're going to start at 9 and we're going to get 3 numbers bigger, 3 whole numbers bigger. So 1, 2, 3. And we end up at 12. So we use our number line to keep track of the problems that we're dealing with. So we start at 9, we get 3 bigger. We would say we would move 3 to the right on our number line. So adding is going to make the number bigger. We can all picture that in our minds, that adding is going to make the number bigger, and we're going to move 3 places up, and we're going to end up at 12. And that's how we're going to use our number line. Now, lots of you will be very comfortable with how to do this already. There's a reason why I'm particularly focusing on the number line, and that's because we're going to be dealing with negative numbers very soon. And if we have the number line very solid in our heads, it helps us with the harder stuff that's going to come in a little while. So it's important that even if you're already comfortable with adding numbers up, that you're still going to use the number line throughout this chapter so that you're ready for when things get more difficult. So this is the first time I've said that to you, that we're going to do things in a slightly longer way so that we're prepared for when things get more difficult. So let's take another example. If we start out at 21 and we take away 8. So we're going to start out at 21 and we're going to subtract 8. So what would that be? How would that be said in English? We're going to get the difference between 21 and 8. So that's how we can use this language here. We're going to get the difference between 21 and 8. So we're going to start at 21 and we're going to subtract 8. Now we know that subtraction is going to make things smaller. So what we're going to do is start at 21 and we're going to move to the left. We're going to get smaller. And the numbers going to the left will always be getting smaller. So we're going to go 1, 2, 3, 4, 5, 6, 7, 8. And we end up down at the number 13. So that's the difference between 21 and 8 is 13. So that's how we are going to use our number lines. Now if we end up with more than one operation to do at once, so if we have 24 minus 10 plus 3, what do we do there? Well, here we're going to take whichever numbers we think are easier to deal with first, but as a general rule, we're going to take the numbers on the left first. So I'm going to do the subtraction here on the left, and then I'm going to deal with the plus 3. So I'm going to deal with this part of the sum first, but I'm going to keep writing down all of my numbers. So I have 24, and I'm going to take away 10. So I'm going to get 10 smaller. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and I end up down at 14. And I still have the plus 3. And you can see here I've written one sum underneath the other. This is going to be really important as we go forward. So we want to start putting equal signs because this line is the same as this line. We've just tidied up the left hand side a little bit. So my 14 came from subtracting 10 away from my 24. So this line is the same as this line. I've just done a little bit of tidying on the left hand side. And it's very important we get used to this way of writing problems because again, we're setting ourselves up for success later on. Because when we come onto something called algebra, which we've touched on a little bit in sets, we're going to need to be structuring our sums very carefully in order to be able to keep track of what we're doing. So what we're going to be doing now is writing down our question, and we're going to change a little bit each time. And as the questions get more complicated, that's going to become more and more important. So now I'm at 14 and I want to add 3. So I'm at 14 now and I want to add 3. Well, adding is going to make me bigger, so I'm going to move to the right. So I'm going to go 1, 2, 3 to the right, 3 bigger, and I end up at 17. So I end up down at, or up at 17. And that's where I stop because I don't have any more adding or subtracting to do. So you can see the structure here. I write down my question. I make a change. I make one change, but I keep writing all of my problem. I keep the plus 3 around, and then I do my next step. I add my 14 and my 3 together, so I get the sum of 14 and 3. And it's really important that from right now we're going to start following this pattern of writing down our sum and changing a little bit each time and making sure that we put our equals in. This is going to be extremely important. If we get used to this structure, we're going to succeed. If we don't use this structure, it's going to make life very difficult as we go on in maths as the year moves on. So that's our introduction to natural numbers. We understand our definition now. We've reminded ourselves of some of our definitions of even, odd, adding and subtracting, and we've seen how we can use our number line to help us solve these problems.